Hello and good morning to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss a very important problem in process synchronization that is called as reader-writer problem. Reader-writer problem, as the name says, has in it two identifiable processes, which are reader and writer. Now, reader is a process that is responsible for performing only read. Again, I'm repeating it. Reader is a process that is responsible for performing only read operation. So, readers are allowed only to read a file. Whereas a writer is a process that is allowed or is responsible for updating a file. So, here by updating, it implies read and write both. So reader is a process that is responsible for performing only read operation, whereas writer is a process that is responsible for updating a file, which includes both read as well as write. So here, reader-writer problem is a problem that tries to establish a mechanism to synchronize the operations of these two processes, which are reader and writer. Now, this is a very simple explanation of reader-writer problem. So in this type of problem, there are two types of processes, namely reader process and a writer process. The reader process performs only reading, whereas writer process is responsible for updating a file. Updating, it includes both reading as well as writing. Now let us go through the impositions of reader-writer problem. The first imposition is that two reader can simultaneously access the file. Again, I'm repeating it. Two readers can simultaneously access the file. So two readers can simultaneously perform read operation on a file. So this is allowed. So two readers can simultaneously access the database. Now, the second imposition is that if a writer and any other process, may it be a reader or a writer, access the database simultaneously, then there will be a chaos. So it is understood. So if a writer is modifying the content of a file, then no other process, may it be reader or a writer, should be allowed to have an access to that particular file, because if done so, then the reader or the writer will be trying to access an inconsistent set of data values. So if a writer and any other process, may it be a reader or a writer, accesses the database simultaneously, then definitely there will be a chaos. So to ensure that such complex situations do not arise, exclusive privileges should be granted to writer to write into the database. So this is a very important point that everyone needs to remember. So in order to ensure that such complex situation does not arise that leads to inconsistent data access, exclusive privilege should be given to or granted to the writer to perform write operation in the database. So these are some of the impositions that are there on reader-writer problem. Now, reader-writer problem can have different variations. So if you refer to different literatures, you may find different variations of reader-writer problem. So here, these are some of the variations that may be there in reader-writer problem. Now, the first one is the simplest one is referred to as first reader-writer problem, which requires that no readers will be kept waiting unless a writer has obtained permission to use the shared object. Again, I'm repeating it. In the simplest form of reader-writer problem, no readers will be kept waiting unless a writer has obtained permission to use the shared object. In other words, no reader should wait for other readers to finish because a writer is waiting. So this is one variant of reader-writer problem. Then the second variant of reader-writer problem says that the second reader-writer problem requires that once a writer is ready, then the writer performs its write operation as soon as possible. So depending on your orientation of reader-writer problem, you can have the way how the reader-writer performs operation, but you need to always ensure that the impositions are maintained. So imposition is that two readers can simultaneously access the database. right? Two readers can simultaneously access the database, and if there is a writer performing an operation onto the database, then no reader or writer should be allowed to perform operation on the database, because it will create a chaos, right? It will create a chaos, and exclusive privilege should be given to the writer to perform operation whenever the writer wants to. Now let us go through a very simple strategy, as in case of producer consumer problem. So here we have formulation of the strategy as well. So here we have taken three different variables. First one is a read count. So read count is a very simple integer variable that keeps track of the number of readers and is initialized to value 0. So initially there are no readers of the file, so it is set to 0. So read count is an integer variable that keeps track of how many readers are accessing that particular file. So it is a variable that keeps track of the number of readers and is initially initialized to 0. Now mutex is a binary semaphore that provides mutual exclusion when read count is updated and is initialized to value 1. So as we have so here we are saying that whenever a read operation is being performed, no writer should be allowed to perform operation on the database. So mutex is a binary semaphore that provides mutual exclusion when a read count is updated and is initialized to value 1. So whenever when the value of read count is greater than 0, then mutex will be used in order to perform mutual exclusion, or to give exclusive right to the read count, or disallow a writer to perform a write operation. Now WRT is a binary semaphore common to both reader and writer and is initialized to value 1. So these are the three variables that are used in reader-writer problem. So we'll learn about the purpose of these three variables in greater detail whenever we will be learning the description of the process in a detailed manner. Now let us go through the writer process. So the structure of the writer is very simple. So first what it will do, it will validate write, WRT, right? Okay, so in order to enter into the critical section, so whether it is allowed to perform write on that particular write operation on that particular database at that particular point in time or not. So wait is a function that will validate the value of WRT. So WRT is initially set to, as we have discussed, it is initially set to 1. So if you see, WRT is a binary semaphore common to both reader and writer and is initialized to 1. So it will validate the value of WRT in order to enable writer to perform operation on the database. So wait will be executed on WRT in order to enable writer to enter into its critical section, or in order to enable writer to perform operations. So it will validate the value of WRT. So let us consider that value of WRT is 1. So since WRT is greater than 0, so it will not engage in the while loop that is defined in the wait. Then it will decrement the value of WRT by 1. So once it decrements the value of WRT by 1, it will grant exclusive privilege to the writer to perform write operation onto the file. So writing is performed. So once a writer completes its operation, then WRT will be incremented by WRT will be incremented by 1 by the signal process, because now you need to enable any reader or writer perform operation on the database, right? Okay, so this is a very simple description of the writer process. So first, writer will validate the value of WRT using the wait function. Then if it is validated, then it will perform a write function onto the file, and then eventually it will increment the value of write with the help of the signal function in order to exit from the critical section. So this is the way how the write process is defined. So it's a very simple definition. First validate, upon successful validation perform write operation, and then increment the value of eventually increment the value of WRT in order to enable other reader or writer perform its operation. Now let us come to the description of the reader process, right? So reader has a little complex structure compared to that of writer. So first, what does reader do is, reader will validate mutex, right? Okay, it will validate mutex for incrementing the value of read count, because we had specified here, if you remember, mutex is a binary semaphore that provides mutual exclusion when read count is updated and is initialized to value 1. So in order to perform updation on the read count, we need that synchronization variable, that is mutex, right? Okay, so here first it will validate the value of mutex. So if mutex is 1, then what it will do, it will perform decrementation of mutex by 1, and it will increment the value of read count. That means there is a reader who is wanting to read the file, so it will increment the read count. So once the read count is incremented, so if read count is equals to 1, now just see here there is a statement, if read count is equals to 1, then wait write. So when there is a reader reading the file, no writer should be allowed to enter into the file. So or allowed to have access to the file. So that is the logic here. So if read count is equals to 1, then you need to validate. So validate WRT. So disable writer to write into the database. So what we need to do is, if there is a reader reading a file, so no writer should be allowed to manipulate that particular file, right? So now once a read count is incremented, once you know that there is a reader process reading a file, and once the writer process has been disabled, okay, so here read count has been incremented. So once there is a read count being incremented, we know that there is a reader into the file. So when there is a reader reading the file, then you cannot perform write operation onto that. So write is disabled. Once the write is disabled, then what we can do is we can allow other readers to come into the reading process, because the first imposition of reader writer process says that you can have more than one readers simultaneously reading a file. So in order to facilitate that, what I need to do is I need to change the value of mutex in order to enable other readers to join the reading process. So now here what I am doing is I am incrementing the value of mutex to ensure that other readers will be allowed to have an access to the file in order to perform read operation. So mutex is incremented by signal, so in order to enable other readers to join the reading process. So once we found out there is a reader, we will disable the writer, and then we will enable other readers to join the reading queue. So perform reading. Then what I need to do is I need to execute a wait on mutex, right? Okay, I need to execute a wait on mutex. So what does wait do? So wait will decrement the value of mutex, right? Okay, so here if a reader wants to leave, so what I need to do is I need to allow an operation onto the read count. So in order to facilitate that, I need to increment or I need to implement wait on mutex. So in order to facilitate exit of a reader from the reading queue, what we need to do is we need to decrement the value of, or we need to execute a wait on mutex and decrement the value of read count. So here what I'm doing is I'm executing a wait on mutex so that read count can be decremented in order to facilitate exit of reader process from the reading operation. So eventually if read count is equals to 0, that means there is no reader left in the critical section. So if the value of read count is decremented to 0, then there is no reader left in the critical section. Then what I can do is I can allow the writer to enter into the writer to enter into the critical section. So in order to facilitate that, what I'll do is I'll implement I'll implement a signal on WRT, right? Okay, so initially writers were blocked, right, with the help of wait on WRT. So now what I'll do is I'll increment the value of WRT in order to provide provisions to writer to write into, or writer to write onto the file, right? Okay, then again what I'll do is I'll signal mutex. So I'll increment the value of mutex. So once all the readers leave, right, so the writer will be allowed to perform operations. So this is the way how the reader process works. So reader process is a very simple process, right? Okay, so as in case of writer process, so reader process also simple process, but here what we need to do is we need to ensure that whenever reader is performing operation, writer should not be allowed to perform operation, and whenever reader is reading a file, there can be multiple readers entering into the reading process or into the reading queue who wants to read that particular file. So in order to facilitate that, what we are doing is we are continuously changing the value of the semaphore mutex. So again again I'll explain the reader process. So initially what we are doing is we're executing a wait on mutex, right? So wait on mutex. So mutex is a semaphore that is used in order to perform operation on read count, right? So we are implementing a wait on mutex, right? So if mutex is 1, mutex will be decremented by 1, so it will be 0, and read count will be incremented by 1. So once the read count is incremented, so if read count is equals to 1, then I'll make the writer process wait. Once the writer process waits, then what we can do is we can allow multiple readers to come into the reading process. So for that, what I'm doing is I am signaling the value of mutex. I'm incrementing the value of mutex by 1, right? Okay, and then eventually whenever the reader leaves the reading process, then I'll be executing wait on mutex and we're decrementing the read count again. So eventually when read count becomes 0, that implies that there is no reader left in the critical section of performing read operation. Then we can give privilege to the writer to perform write operation by incrementing the value of WRT. So this is the way how reader process works. So in this particular class, what we have learned about is we have learned about a very important problem in synchronization. That is reader-writer problem, where we have learned that readers and writers are two different processes that are performing read operation and write operation onto the to the file. Read basically means only read, and write basically means updating, where updating refers to both read and write. And we have also come across the impositions on reader-writer problem, where we have learned that two readers can simultaneously read the file, and if there is a writer and any other process trying to access the database, may it be reader or writer, then chaos will be created. In order to avoid such complex situations, exclusive privilege is granted to the writer to perform write operation onto the database. And we have also learned about the variations of reader-writer problem, and then we have discussed the strategy that is to be pursued for synchronizing the readers and writers. Okay, right? Then we have discussed the writer process. So writer process is a very simple process, right? So first it will validate the value of the semaphore. On successful validation, it will perform write operation, and then again it will increment the value of write. Whereas in case of reader process, first we need to implement a wait on mutex. So mutex will allow operation on read count. So if the read count is incremented and it becomes equals to 1, then you need to disable the writer, disabling it from performing write operation. So once that is done, you can allow multiple readers to join the reading process, right? Okay, and once the reader wants to leave, then you need to decrement the value of read count again through wait operation on mutex. Eventually when read count becomes 0, then you can allow the writers to come in and perform write operation. So this is the way how reader-writer problem is defined. Thank you very much. Have a very nice day.